Can everybody hear me? Yeah, okay. Hi, I'm Arvind. I'm a developer at Stayzilla. How many have heard of Stayzilla here? Okay. So I just 1 minute on the business and I'll move on to the tech part. So we started off as a low budget hotel booking portal, and we've now moved on to become a marketplace for stays. So if you have like your home, a room in your home, you can basically get onboarded on Stayzilla through our app. Okay. So the topic of this presentation was our journey our journey to microservices from monolith stack. So the way essentially this journey is going about is we have to maintain a balance between what the business wants and what developers want. So basically, business wants new features, additional functionality, but we as developers, we want to roll out changes quickly. We want to, we don't want to work on huge legacy code bases. I mean, it's just a pain, debugging like a 500-line method. So yeah, so we're trying to maintain a balance, and through the journey, I just show like what we've been doing. So along with each phase of the journey, I just highlight the issues that we've encountered, because for a lot of people that would mean much more than just saying what we've done. So we started. What we were given about a year and a half ago was so there was one developer who was on the entire code base for about a few years. So what we had was we had a box where the production side was running. It was on the LAMP stack. We were using SVN, so the deployments were basically, because it was on LAMP stack, you don't have to do any builds or anything. So the deployment was just SVN up on the production. And we had like, I think about 10 to 12 files. They're like the core files of the system. All of them are like a few thousand lines each. And no principles followed. It was just like a hacker trying to code and get business going. So the code was very like you had so you had a file and then you just had one big function. It would have the SQL queries, you would do looping, you would generate your HTML right there, you would echo it. So that was basically what we had. So the first thing we did is, it's not easy. You can't just say, okay, I'm going to move to a new service and just, start building new services and, wire your front end. That doesn't work because this is an existing system, a lot of rules incorporated. So what we started doing is we started making small changes on the code base itself, trying to fix some defects. We also did a little bit of refactoring, so we moved corresponding components into like folders. Not exact. So you could call them modules. And we also, over time, we also incorporated libraries such as Twig to render views, and we also use it for mailing to compile templates. And we also, we finally added log for PHP through Composer. So some of the issues we actually came across while we were on the monolith PHP were the include once problem in PHP. So if you're including multiple files, in that one file file A might have file B, include file B, but file B might be including another file. So what would happen is you have duplicate declarations of your functions, and the code would break. And you might not know this on local, but if you're on production, it might affect you. You will usually see the issue on production. Again, because there were no OOPS principles, nothing boxed into classes. The functions, we had functions with the same name in multiple files. Because we didn't have environments, we were not able to replicate a lot of issues on our development box. So we used to debug using echo statements on the production itself, especially in places where, I mean, for user-facing components, it was a little difficult, because the user can see it, but for operations or any internal tools that we use, that was not an issue for us. But now that we have log for PHP in place, we just go and log. So that's the benefit of actually being on PHP, even though it doesn't scale too much. You can just edit on runtime. So that I think saved us predominantly. Also, there were a lot of cron jobs all over the place on the production, so you don't know. You would have some code reading from a table, but you don't know where the writes are happening. So we had to sort of, as we enhanced the functionality, we kept pulling in the crons from the production box and putting it under version control. So one of the things we did early on was we moved out of Apache into Nginx and PHP FPM for thread pooling and non-blocking nature of the request that Nginx has inherently. So one of the problems we faced quite a few months ago was that we bumped up the number of PHP FPM threads, the maximum threads. So what happened was mostly our PHP application would be waiting on the database to get some data. So when our database load was high, more threads were being created, and our production instance was becoming, started grinding to a halt. Requests were just timing out. Nothing was happening. So, we reduced it. I think there is a certain they give a certain recommendation on how many you should have based on how big your machine is and number of cores and the RAM that you have. Okay. So the next thing we did was obviously we needed environments and like a deployment process. So when we first started, we were a team of about 8 people. So we started with these basic things. So we use Jenkins for our CI continuous integration. Basically we use Fing to build our PHP code base. The main things that the build used to do was to do our DB migrations and minifying of our JS and CSS files. And we also set up a QA environment so that we can replicate issues there. Our builds would deploy to QA on every check-in. And we also put up monitoring using Nagios. We used the checkmk OMP. We moved completely from SVN to Git. So as I mentioned, the build, we use Fing for that, for the PHP code base. We also had an analytics system, open source analytics system called Pivik. So it's an equivalent to Google Analytics. It gives you most of the functionality. You can self-host it. So we moved that out to another system, which is Pivik is also PHP based. So we moved that out to another box with again we moved that out of Apache and used Nginx there also. So one of the things we did was to get to close to a zero downtime. We had deployments to multiple ports on multiple machines, so that while one deployment is happening, the other instance on the other machine would be up. So yeah, this gives quite close to zero downtime, but just when the restart happens, not on our PHP application, on our node, you would get an Nagios alert saying that the app is down. So some of the issues were that while we were moving to Git, it took time. So we couldn't stop pushing code. So a lot of SVN to Git rebasing had to happen. It had to be done quite a few times. And because we were using PHP, sometimes we would bypass the deployment process because we just want to check if something works on production. So we just go and change something there. So sometimes you have 10 commits which have not been deployed to production, and you have 5 of them that are in, 5 of them that are not in. So I mean, we try to resist doing that, but it's fun. I mean, because you just get it onto production quickly. Um, so we started our breaking out of the monolith from the top down, basically. So we started with the front end applications, not with the services and the core logic, because at that point in time, we needed a much better user experience on the front end. Like, uh, because we were a small team, we were only 8 at that time. Uh, the monolith wasn't the biggest bottleneck. I mean, in terms, I mean, there were some requests that are taking time and all of that, but at that point in time, that was not the priority. So what we did is we chose Node for the front end. I mean, I think naturally these days, I think Node, if you compare it with other technologies, I think because of the nature of isomorphic JavaScript, I mean, Node sounds like a no-brainer for front end applications. I'm quite biased towards Node personally. Uh, so we started with the mobile side initially because we didn't have a mobile-friendly website. So we use Node there, and we sort of trimmed down on. I mean, we just used the basic. We didn't put any heavy frameworks like Angular or Ember or anything. We just used native, not even jQuery. So we use Zepto. It has mostly jQuery compatible API. There's certain like animations and things don't work. I mean, they're not available on Zepto. And in our mobile side, we use require.js and handlebars for templating. Later on in the year, we also moved our desktop side to Node.js, and there we use jQuery, and we also incorporated Browserify instead of require.js, which allows you to write your client all your scripts like you write your Node code. So you can use require like the Node require um, to write even your client-side scripts. Um, and again, handlebars for templating. So we didn't go for any Ember or Angular here. I mean, we chose to stay away from that. So some of the issues we had was so with require.js. I mean, it was quite a pain, especially when you had the same code on server side and client side. Because on server side, you're writing in Node style. In the client side, you have to put in your modules. So that was quite painful. So Browserify, I mean, with Browserify that was a piece, so we could use the same code across. So in a PHP application, so the front end basically what we did was the Node applications used to talk to PHP for any data operations or any business operation. Front end was more like just for the UI and I used just for the it was just for the view mostly. So we have like, I mean, with the front end now, we had endpoints, I mean, which could be used. Like this is, it's like a start to microservices, but it's not completely microservices because everything, all the logic is still on the monolith. So one of the problems of PHP code base is we have like random die statements in the, in if like a database query fails. So we have to handle these sort of responses. So on Node, your JSON.parse would throw an exception, and especially on Express 3, our mobile side used to keep restarting. I think with Express 4, with the middleware that we added, we didn't face much of a problem there. Also with Node.js, because of its single-threaded nature, we, some things on production used to block our requests. They just used to die off. So we used to use, so because we deployed on multiple instances, we used to run this tool called node tick processor on one of our instances. And that would give you, so if you run it for about 15 minutes, you would get like a report of which functions are actually taking too much time. So that was one of the things we used to do. And again, this is very difficult to simulate on a local machine because you don't have that much load. Maybe if you do some performance tests, you could. Also, when we made requests like parallel requests from our server side, from the nodes server to our PHP code base and external code base, the time of per request used to go up like from 2, 3, 5 seconds. The reason was we were on node point 1 and there the global max agents value is set to 5. So that means only 5 connections go out of your node. So in node point 1, 2, I think that issue was fixed, and so what we did is we upgraded to node point 1. So the next thing we did was, so once this was done, there were a lot of heavy database queries that were slowing down the production. So what was happening is while we were doing all this, parallelly business was ramping up traffic. So these database queries started to take a big, hit on the performance of the system. So the database used to go down. I mean, it used to be slow. That it used to, the effect used to just percolate across the application. So our application would start behaving. They start throwing exceptions. So then we have to, restart application. It was basically like firefighting. So what we did is we started looking at what queries were taking time. So on MySQL, we had the slow query logging, so we used to see that. So we used to run a chat system on polling. So like every 5 minutes, it used to poll. The client used to poll the database and see, if there are any new chats. So then there were a lot of very data-intensive queries there, and with a lot of joins and all that. So we moved that out to WebSockets. We use Socket. We evaluated a few frameworks that are there and found Socket IO to be good. And we also added Redis there for caching. So, like basically on load, you get the user messages. So those are all cached. So people who come regularly, they would just. We need not keep hitting the database. Not even regularly. Even if you're on one page and you do a browser refresh or something, the next set call won't go to the database. It will basically be on to the Redis instance, and it will exit off there. So that caching really helped. So that really reduced the load. The next thing that was taking time was our lat long search. So basically, if you look at our website, it's powered by Google autocomplete. So the lat long is passed to our server, and it used to be the search used to be a trigonometric function on the MySQL. I think there's a certain formula for that to find like places within a certain range. So we moved that over to Elasticsearch. So yeah, and also we have our own autocomplete feature. So the searches that was being used by our employees, to suggest locations to people. So we moved that also to Elasticsearch. That's basically like a string matching, stripping off the vowels and all that. So we moved that to Elasticsearch too. So for our marketing landing pages, we used to have like files which are cached. So there was a cron which used to generate a whole bunch of files, so when high traffic comes, the user will just read the files. Now the problem with that was that anytime you make a JavaScript change or anything, you need to invalidate all of that cache. So what we do now is we cache the data and not the files. Even here, there is a slight problem, but it's much easier to invalidate a whole bunch of keys on Redis rather than going in and removing all these files. We also we were running on only one database, so we sort of balanced the load. So for some of our operations which don't require real-time data, we moved those calls to a slave database, so that the master, the production database doesn't get heavy load. So these were some things that paid off, and yeah, I think it's helped us scale quite a bit. So I think so when we started, we were at about 3,000 to 4,000 UVs per day, unique visitors. Now we're at about 20,000. So some of the issues we faced with these features or things that we did was basically WebSockets. We had a hard time finding out. So what used to happen is for our chat messages used to go randomly. The reason was we had So when a user is or when our team operation agents were browsing on multiple tabs and they close one tab, we used to treat it as like them leaving out of the system. So it took us like 4 days to find that out, although it was like, I mean, it's such a straightforward thing. So, I mean, if anybody is working on WebSockets and you're writing your own implementation to handle users leaving your system, then just, make sure that you're aware of this issue. So we basically, we have a cookie for all our users. So, we use to identify the user with that cookie. So when you used to close one tab, we thought that guy is gone. So yeah, that was a problem for us. Also, one of the issues is that the slaves. So sometimes the queries that run fine on your master won't run properly on your slave. So the slave would go down. We're yet to implement some monitoring on the slave. We've not done that. So most of our tables, the problem is because this is like almost like a 10-year-old system now. Most of our database tables are running on the MyISM engine. So you have to do repairs on these tables, and that for that you need downtime in the system. So we thought we'd move some of our MyISM tables to InnoDB, but what MyISM gives you this feature called insert delayed update low priority. So it's like you're multi-threading on the database. You just push off all the low priority stuff to delay loss. So when we moved to InnoDB, so systems started slowing because we moved some of these insert delays to inserts, and that was taking time. So these are some of the things we faced. So now, in the beginning of this year, our team grew and we needed to release Android and iOS apps, which had a feature requirement which is a superset of the current feature set. So this is when we consciously took a decision to move to microservices and smaller applications. So as I say, the journey is still on. We're not like completely into microservices yet. But I think we've done a fair bit. So the way we start, any new features, fine. You just write them. It goes off. So we have like an API to upload pictures, and for our people, for the users on the app, who register the stays. That's all fine. You just you start the service. You have your own persistence for that, and you move it to production. But for the existing features, we can't do. It's not easy to do a big bang rewrite. So what we did was, so on our mobile side and desktop side, when we rewrote it, we kind of structured our endpoints. Although it wasn't like, we didn't sit and discuss like contracts, but it was more. Those endpoints were more or less like they're designed as contracts. So we pulled those out, pulled it into a microservice, and wrapped additional functionality that was needed. One thing I missed here is that again here also we chose to go with Node. So we're using the same technology across, so that it's easier for developers to move from one code base to the other. We have a couple of services on Java. That was like a knee-jerk reaction when we encountered the global max agents issue on Node. We thought, okay, let's write services on Java. But then once we found out this problem, we thought, okay, let's stick to Node for services for now. And we don't use Express because or any other application framework that has all these view rendering capabilities, because our services are purely JSON and REST compiling. So we chose to go with a framework called Restify, which just has like the bare bones, REST, the bare bone things that REST services require. We also added logging using Boolean. Most of the services use Boolean. So the benefit of microservice, you can, in your new service, you can try something new and share it across to people. So we use the Boolean, and one of the things that we have done is because we identify our users uniquely with a cookie. So we use whenever we're logging anything, we log that. We make our log statement with that particular ID, so that if you're analyzing logs across the services, you can see, okay, this user has come, he's come to this page, he has hit this service, then he has hit this service, and this is where the problem is. So for that, the ELK stack helps Elasticsearch, Logstash, Kibana. So basically, what will happen is, so your app logs into a log file, and Logstash will basically pick up this and forward your these log entries as they come to an Elasticsearch instance, and Kibana is a framework for the dashboards. So you can get a dashboard with all the logs. You can drill down, and also you can drill down to a user level or cookie level, and you can also see like overall what's happening. So the deployments, because we had our CI set up for each of the services, I mean, they had their own deployment pipelines. Again, but there are some times when the monolith still has to be moved. So what we have done now is like the monolith PHP application is managed by like a small team, and the others are writing the services. And we also use the Swagger to document our APIs. So with Swagger, you can just on top of your request or routes, you can just they have their own syntax to write what is expected, what is the response, and you can even try it out. So people who are consuming the services, they can try things out before they actually implement. So this gives, as I was mentioning, the advantage of the microservices is that there's a flexibility to experiment with technologies, because I mean it's very difficult to introduce something new to big service or big monolith that's been running for ages, because you're scared it might affect something existing. But with microservices, you can just try something out, and if it works, you can push it and start redirecting some of your traffic there and see if anything is working. So yeah, so some of the issues while we were writing microservices, we've also moved a lot of the build processes to use Gulp. So on our front-end applications, we use Grunt, and Grunt is a little slow because all the steps are synchronous. So basically, Grunt and Gulp are node-based build tools. So in Grunt, everything is synchronous. It's like you do A, then you do B, then you do C. But in Gulp, you have the flexibility. You can say C depends on B, and A can run alone. So the build times are much faster with Gulp. So I think most of our new code now we use Gulp to do the builds on node. And one more thing I missed out is that we also do our deployments using Grunt and Gulp scripts. So like we have the deployment scripts on the code base, and so it's very clear for a developer, what happens, how the service is on your environments. So some of the issues that we've faced while doing this move to microservices is so because you have microservices, developers just think, okay, right, let's, you expose the API, you make the corresponding database calls, and you're done. But the problem is now you have duplicate code. You probably have the same, select star from A in like 5 microservices. So that's where, people need to get together and talk and say, okay, look, this service is going to do this, and this service is going to do this. So moving to microservices actually makes it a little more, you need to have proper people interaction. You can't just, people can't just go on coding away. Also, another problem is that people are reluctant to add on to existing service. They're just, happy using a generator, generate a new service and push it to production. So that way we've got a few services which are like really small. They're just like 2 HTTP endpoints of the service. whereas they could have gone to something much more general. So it's very important to maintain that balance. I think if the first problem is fixed, the second problem would be fixed. So you say that I have a user service which talks only that service talks to all these tables that are related to users. Then automatically people start writing on the user service itself rather than saying I have another service to reset the password or something. Again, so this also led to duplicate code. So you have the same code across the services to read from your database or do some calculations. So that's one of the major issues that we face with microservices. So what we want to do going ahead, so right now we only use like a couple of machines, but we want to move, so in short term, mid term, we want to at least we want to move or distribute our services to 4 or 5 machines. And when we really scale, we want to look at the possibility of using cloud and auto scaling of services, using containers. One of the things with Swagger is that we've not actually added to the applications. We've actually generated a separate JSON and put it in a common place. So that makes so that your documentation is actually decoupled from the code, which is not good. So we want to look at moving that back into the applications. And we do very limited test-driven development. It's there, but we need to follow it much more religiously. Otherwise, it's very difficult, to know who's making services and what's happening. So some good reading on microservices. So one of my colleagues, Kishore, he wrote a post on LinkedIn on this journey that we have taken. It's definitely a good read. Also, I think Netflix, they have some good, good documentation, good libraries on microservices. And there's a book by Sam Newman. He's a thought worker. It's called Building Microservices. It's a good read. So he covers. What I've just mentioned is like very, shallow. He's gone into much more depth in the book in terms of he talks about your infrastructure automation, your security, and more aspects as such. He even talk. I think he'll also talk about how you should structure your company. I've not reached that part. Cool, guys. So that's it for me. Any questions?
One simple question. So, in microservice, I understand the advantage is that you can deploy just one component or one service incrementally.
Yes.
So, what happens to the live user sessions? That's one. And secondly, should you restart any? Obviously, you're not going to restart the entire SAP server.
So the thing is that one of the benefits we had was that our user sessions were not tied to the application. We had already moved that out to the database. Or you could also use you could use Redis so that your reads are really quick. So that's one benefit. So that's a must. You must move the sessions out of the application. Otherwise, it won't work. There are ways, but it's the best thing to do is to move it out of the application. Secondly, one thing I forgot to mention is that we also, in our microservices, we also added like middleware for the versioning. You can use this SEMVer pattern, semantic versioning. You have major version, minor version, and patch. So any breaking changes can go. You can add a major version. So that we're still at 1.0 of all our services, so we've not gone into that phase, but we have the support for it. So if the 2.0 has like a response that's completely different from the 1.0, then the 1.0 guys would still be calling the 1.0 API, and the new consumers of the service can call 2.0 API. And again, this is where the communication is very essential. So you need to inform all your consumers that you're going to deprecate this uh, in some time, with the microservice you don't have to carry a whole bunch of baggage. Otherwise, what will happen is your microservice will become like a bunch of legacy code.
So the second question is the abstraction of the tables to service the only solution as far as the database is concerned? Because as I change the services, my tables also could change. So it's abstracting, separating as the only solution. Is there any other solution which you tried it?
We've not tried anything as such, but yeah, that's or you could another approach that Martin Fowler suggests is polyglot persistence. So each of your services has its own persistence that allows you to. So we are using the same database. We've not changed our data store, but if each of your services uses their own data store, then it might, then you not have this problem because, uh, like, the consumer of the service or the guy writing the other service, it will be a little more difficult for him to figure out because it's a different database. He won't have that set up in his development box. So it might be easier for him just to call that service and get the data. So that's also another approach, and I think that's more widely followed. Any other questions? Okay, cool guys. Yeah.
When you're shifting from monolith, we are actually separating the services. Right?
Yeah.
So presently we directly query the database to get some results. So now what happens is a single application will call some APIs to another application and it will connect the database and the result comes. Was there any latency and how do we handle this?
Okay, I think so. I just repeat the question so that everybody can hear. So the question is on HTTP latency and is that affecting the performance? So far as we've seen, no, it's not affected the performance. If you keep all your services within network, so we've only deployed a couple of machines. So one machine talks to the other using private IP. So the latency is just too low. It's negligible. We've not faced latency issues of this level. Yeah.
Is it, I'm just asking your opinion.
Huh.
Is it a good practice to have a single database but different app servers has different services?
That depends on your need. Actually, if you should have. There's a fine balance. If you want, yeah, if there's a real strong, compelling reason to move a particular service to another data store, then yes, you should go ahead.
We're not asking about data storage. Instead of firing the API, why not the service actually directly query the database and get the running data?
No. So you would have, if you have 5 services, so you have one for users, you have one for maybe shopping or orders. So the order service would query your order tables. Your user service would query your user related table. But for anything related to orders of a user, you would hit the order service so that your order logic is not duplicated in your user's service. Is that what you meant?
If, say for example, if the order service needs some users data,
Yeah.
Is it right to directly hit the users database?
That's what it's preferably no, because you start now. You hit the database, then you say, okay, now the user name is stored this way, so you need to concat your first name, last name. So you do that in both the places, and then you start doing more and more computations. So what happens? Instead of having a one monolith, you have it now in 2 services. So that's why it's not recommended to do. It's better to separate the data. Yeah.
So that goes back to your question of what is the boundary. So if you think you are in a phase where my order is growing, my users are growing, I can't draw a clear boundary between the two. You see it as one and the same, it's one service. If your business is in such a way that by definition I want to, let's say, take orders, order is going to evolve on its own. My user, I have a fairly good user. I'm going to expose what user can do in an API. So that has a life cycle on its own. That is your fundamental principle that decides how many servers, what is your granularity of your service. So if you decide that way, it's like what applies to class applies to a service. I should not know too much about, it's still don't ask principle, right? I mean, I can't know too much about your internal data. If you say I will have 1 DB and I have 2 services, in the end I will know what table, what column, what data type, then where is independent evolution? Yes, there is nothing wrong, you can do it. In the end, if you're going to have only one Postgres or one MySQL, you can still do it, but that defeats your own purpose. Yeah.
Any other questions? Cool, thanks. So we're hiring developers with experience. So we've got a bunch of freshers already, so we need some experienced guys. So at Chennai and Bangalore, so please write to us.